Park.
Okay, here we go.
My stock is rising.
The pencil sharpener is there the whole year. So you use once. Because only now you're probably going to write something, right? For once in class.
You gonna copy the answers off the board? What?
Okay, oh, how's fishy? Most of the problems are even. Number 2. Okay, we're at 7.3. Number 2. Cross sections are squares that lie in the XY. Okay, look. You guys understand the region first of all? The region is a circle. And they give you the equation of the circle, x squared plus y equal, for the video. X squared plus y squared equal 1. But then you have to solve for y. So if you solve for y, you get y squared equals 1 minus x squared. And then y equals plus or minus the square root of 1 minus x squared. So what's the equation of the top semicircle? Y equal root 1 minus x squared. What's the equation of the bottom semicircle? Negative root 1 minus x squared. Did they actually tell you that in the graph?
Yeah.
Oh gosh, they did. I just gave you extra information there. Okay, now, you make the rectangle now. So it's like you put this on the cutting block and you slice it up like this. If I remove one of the slices in part B, it says, no, we're doing number 2. Why am I even doing number 1? Well, since I have it on the screen, let's do 1. Okay, I'll do A, B, C, or D. A, B, C, or D. And look, they even give you pictures. Which one? C.
Erase the 2 and put 1. That way we're not confused when we watch the video.
You guys are confused.
Okay, anyway, so you remove a slice, and what you're going to see is a square like this. This diagonal of the square is lying right along this rectangle, like that. That's what you've got here. So what is this length right here? What is that length? Which is this? How do you figure out the length of a rectangle? Top minus bottom. So what's top minus bottom?
2 root 1.
2 root 1 minus x squared. Now, if you know the length of the hypotenuse or the diagonal of a square, can you figure out its area?
Square divided by 2.
Or how about in a 45, 45, 90 triangle, if you know the hypotenuse, how do you get the leg? You divide it by root 2, right? So if you know what the side of a square is, you just square it. I'm going to leave the simplifying to you guys though. So this is the diagonal, divided by root 2, square it. This tells you the area of this square right here. But there's a thickness to it. dx. How come it's not dy? Because the rectangle is vertical. You believe it or not, people, the rectangle tells you everything about how you're going to do the integral. I noticed some of you still not writing the dx and dy. That's like blows me out of the water.
Did you grade our homework?
Silence. Then you add up all of these square thingies from negative 1 to 1, but we have
0
symmetry.
times 2.
0 to 1 times by 2. Now, in these problems, are you guys supposed to actually compute it or just write the integral? What does it say on the directions? Some of you don't even bring your book. How do you even know what the directions are? Compute the volume. Okay. I will leave that integral. And can you see that once you square the radical, it's just a polynomial?
It's nice. 2 minus 2x squared, because I did the homework. Then you find the integral with that.
2 minus what?
Okay, now we do number 2. Okay, number 2. Okay, let me get this picture straight. So we got, and then we cut it like that. So we have a parabola opening to the right, like this. Up until where? Is it 4? Yep. So this is 4 over here. And they tell you the equation of this graph is x equals y squared. But if you solve for y, you get y equals plus or minus root x. So the equation of this top part is y equal root x. The equation of the bottom part is y equal negative. See, the book gives you simple problems because the top and the bottom, I'm going to make them 2 separate equations. That's less alike. Okay, then I pick an infinitesimal slice. So you put this on the cutting board and you slice like this. Okay, now which one are we doing? I'm not going to do them all. Which one are we doing? D? Okay, D, equilateral triangle. So if I remove, so it's like you have this three-dimensional thing here. Huh? If I were to remove this slice, you're going to get an equilateral triangle like this. The base of this triangle is lying right on this rectangle here. See, like over here, you get small equilateral triangles, and they get bigger. Remember how last week I tried to draw the picture for you? You want me to attempt it? Do not attempt this at home. Okay, so which way is it going? It's going to the right like this, yeah? So it's kind of like, ta-ta, ta-ta. Let's start from the back. So the equilateral triangles here are small like that. Then they get bigger and bigger and bigger and bigger. So it's kind of like a Gila monster's tail, yeah? Except you cut it right there. Cut off the Gila monster's tail. Anyway, so this is the length of the rectangle. And how do we find the length of the rectangle? Top minus bottom, which is 2 root x. And if you know the side of an equilateral triangle, can you figure out its area? Did you guys memorize the formula yet? Root 3 over 4 times the side squared. But it has a thickness to it. Dx. And then you add up all of these equilateral triangle slices from
0 to 4. Because that's what it says in the book. And that's what it says in the book.
I don't want to hear your voice ever again. Not just this class period. Okay, so pretty much, okay, number 2, it's the same thing except you just get different shapes every time. So can we move on to 4? Or we got to do another one? If I'm going to do it, you guys better write it down or something. Some of you are just staring out into space. Yep. Okay, I'll do one more from number 2. Okay, so which one? You guys tell me which one. A, B, or C? Okay, let's do A. Let's do A. Oh, I did A. But that was actually B. That was D. Okay, let's do A. Okay, so if I remove the slice in A, if I were to remove the slice, you're going to get a circle where the diameter is lying right along the rectangle right there. Jaime Escalante calls it the strip. Okay? And what's the length of the rectangle again? Top minus bottom. So if you know the diameter of a circle, can you figure out its area? Yeah, the area of a circle is simply pi times the radius squared. But if this is the diameter, what's the radius? Half of that, which is root x. But it has a thickness to it. Dx. Add up all of these discs from 0 to 4. And that's a really easy integral because that's just x, right? Okay, let's move on to number 4 already. The solid lies between the two. See, it doesn't matter. It's the same problem over and over again. You got a top graph, you got a bottom graph, and you got a slice. It's the same thing every single time, except it changes. And then what does it say? Cross sections are circular discs. It's the same thing as this. You should be ashamed of yourself. So what was it? Y equal x squared, I believe. And y equal 2 minus x squared. So this is the region right here. Put it on the cutting board, slice it up. If I remove a slice, you're going to get a circular disc like this. The diameter is lying right along that rectangle there. So how do I find the length of the rectangle? Top minus bottom. So which one's on the top? This one. And so top minus bottom is 2 minus 2x squared. Can I just simplify it like that already? Okay, so again, if you know the diameter of a circle, can you figure out the radius? Yes, it's half of that. So the area of the circle is pi times the radius squared. But the radius is simply half of that diameter, 1 minus x squared. But it has a thickness to it, dx. Add up all of these circular discs from. Oh, Mr. Park, we never figured out these points of intersection. Okay, just by inspection, guess and check. negative 1 and 1. So, shall we go 0 to 1 and times it by 2 since we have symmetry? Yeah, and some of you are not doing this, but I'm telling you, it's way easier to plug in 0 into the antiderivative than negative 1. Because some of you are making mistakes plugging negative numbers. So this one, you're going to have to multiply that out to do the integral. Are we getting the hang of it now? So, here. No. Just move on to the next problem. Top minus bottom, number 8. Whoa. Okay, I will do one of these. Which one? I'm not going to do both. Number 8, A or B? And anyway, for those of you who actually did this problem, if you do one problem, the other one is the same thing except with a different constant in the front. Yeah, did anybody notice that? Nobody's going to chime in, like pretend like they did it? Okay, hero? And those of you leaving, who's leaving this class? Who's going on the trip? Okay, hero, and who else? Oh, you're leaving tomorrow already. So then, how far ahead did you work?
I worked 7
Oh, you did, the discs. And what about the 2 after that? Mrs. Fujinaka sent me an email saying, the following students are going to the island of Kaholabe. They should be seeing you to how to make up their work ahead of time. Pamela Fujinaka. No, I'm serious. She sent that email.
Is that homework you did?
No, on the day of the test, but she said you guys can make it up before you leave. That's how it goes, people. The only time you're allowed to make up work is when you're sick. Otherwise, you go on a trip like that, you gotta make it up on your own before you leave. That's the way it is, man. Okay, number 8. I'll just draw the picture and then you can decide whether they're doing A or B, okay? We got negative pi over 3. And again, I think a lot of you have problems just drawing this graph. Tan x looks like this. And secant x looks like this. Wait, root 3, so 2 is up here, yeah? Secant x is hump up, yeah? Hump up. So this, ooh, that looks like well, I'll see, the only thing that's different is the top and the bottom are 2 different equations, right? Like this one. You got that equation, you got that equation. Oh, you want me to give you the graph? Well, some of them I might give you the graph, but the basic ones, like these are 2 like base trig functions. You gotta know those, right? Secant and tangent, right? Okay, so here's the region. I put it on the cutting board. If I take out a slice, okay, are we doing A or B? Somebody pick one.
A.
Okay, A. A says the cross sections are circular discs. That's the same as the last 2 we did. You don't want to change it?
B.
Okay, squares. Okay, so if I remove a slice, this is on the cutting board, I take out a slice, it's a square. The base of the square is lying right on that rectangle. So what is the length of the rectangle? Top minus bottom. Secant x minus tangent x. And if you know the side of a square, how do you figure out its area? Duh, you square it. Secant x. Oh, look how quiet is this? Heaven. Multiply by the infinitesimal with dx. And then you add up all of these from ring. Can I go 0 to pi over 3 and times it by 2?
No.
Why not? Yeah, you don't have symmetry here. So this one, you have to go from negative pi over 3 to pi over 2. Now, do you want me to actually do this integral?
Yes.
Okay, that's what I thought. You guys, no, for real, if you compare yourself to other years don't have any problems with that integral already. There's no problems. This year, we got problems. Okay, so the only way we can do this is by multiplying it out. So what do we got? Secant squared x minus 2ab plus b squared dx. Okay, that's on the list. That's on the list. What's the only way in the whole world we can integrate tangent squared?
X plus x.
What? replacing it with the identity secant squared minus 1. What is going on? So simplify. See, some of you guys don't even simplify. Okay, you've got two of these. 2 secant squared x minus 2 secant x tangent x minus 1. Now, we can do it. So what is this? What's the antiderivative? 2 tangent x minus 2 secant x minus x from negative pi over 3 to pi over 3. Can you take it from there, or should it go one more step? Come on, you. Okay, so tangent of pi over 3 is root 3, so 2 root 3. You know what? I remember last year I put this exact same problem on the quiz. 2 people got it. Minus 2 times 2 is 4. Because you guys just copy, you don't even know what you're doing. Tangent of negative pi over 3 is negative root 3, so negative 2 root 3 minus 2 times 2, that's 4, plus pi over 3, and lots of things, well, some things cancel out, yeah? Not everything. Only 4. Yeah, just these two cancel out. So let me just write the bloody answer. 4 root 3 minus 2 pi over 3, box that's the answer. Now, when you do part A is the exact same integral as this, except there's a constant in the front here. So all you have to do is take this answer and multiply it by whatever constant was in the front. Yeah.
For part B, couldn't, instead of changing tangent squared x to secant squared x minus 1, couldn't you just use the identity tangent x minus x?
That's not an identity, that's the integral.
Oh, well,
Yeah, that's the same thing because this is tan x too, so you add them together, you get 2 tan x, right? See, you guys are not doing what I'm telling you to do. You guys are just memorizing the antiderivative. I'm telling you, don't do that. Memorize the identity, because what happens instead of tangent squared x? What if on the AP exam they give you tangent squared 3x there? What's going to happen then? Is your way going to work? It rhymes with mole. No, it's not good. How come why are you guys not doing what I'm telling you? No, I only taught calculus for 20-something years. I don't really know what I'm talking about. I only graded AP exams for 6 years. I don't know what I'm talking about. Number 9. The solid lies between planes perpendicular to the y-axis.
Number 9 is
I'll get to the bottom of this. Okay, this is a guy's writing, because it's got that little notch there. Huh? And this little curly Q there means demented. Jim? Possibly Asian descent?
You haven't eliminated anybody.
That's racist. Got a video going. Racist things. Number 10. Okay, here we go. Come on, we got these semicircles. Aren't you tired of these semicircles? Oh, but see, it's perpendicular to the x-axis now. Okay, so when you make your rectangle is going to go this way now, see? Which means you got to solve for x, because the length of the rectangle is going to be right minus left. So if you have x squared plus y squared equal 1, if you solve for x, you get plus or minus root 1 minus y squared. So this half of the semicircle is x equal root 1 minus y squared. This half of the semicircle is x equals negative 1 minus y squared. Did they actually tell you that? No, this time they did it. Okay? Now, if I take out a slice right here, boom, the slice is an isosceles right triangle. This is one of the things we did last week. Come on! Okay, the base of this thing is lying right on that rectangle. So what is the length of the rectangle? Right minus left, which is? And if you know the base of an isosceles right triangle, can you figure out the area? Yeah, remember I told you last week? Yeah, it's half a square. Look. Look. It's half a square. This is a 45 9. So what's the area of the whole square? This thing squared. So this thing squared, and then half of that. This is just geometry. But it has a thickness to it. It's dy this time because the rectangle is going that way. Add up all of these rectangles from, slices from -1 to 1, or do you want to go 0 to 1 and times it by 2? That's a dumb. 0 to 1 and times it by 2. So if we were to have a quiz tomorrow, it would only be on slices. But then we have a quiz on Thursday. It's going to include this next thing, Mr. Revolving. Here, well, okay. Why don't I show you what we're going to learn, and then I'll make the decision. I'll even pretend to entertain your decision. Okay, now what's going to happen? We call these solids of revolution. Okay, let's say we have an axis of rotation. It can be the x-axis. It doesn't matter what it is. It can be a line. Now, tonight's homework is this. What would happen if you make a rectangle of infinitesimal width, and it's actually touching this axis of rotation? If this rectangle gets revolved around it, like that, what shape do you get? Okay, it's a cylinder, except the height of the cylinder is infinitesimally small. So we don't call it a cylinder, we call it a
Circle.
disc. A circle doesn't have a thickness to it. A disc is like a poker chip. You know what I'm talking about? Okay, now, if this is the radius of this disc, how do I figure out its volume? You gotta be joking me, people. If you had to find the volume of this, wouldn't it be the area of the circle times the height? Because it's a cylinder, right? So pi r squared is the area of the circle times this infinitesimal thickness. Now, is it dx or dy? It's dx because you drew it vertical. I'm telling you right now, some of you don't believe me. The key to the whole thing is which way you draw your rectangle in. You draw it in the wrong way, say goodbye, Charlie. Okay, now tomorrow's lesson, this is for you, Tom. What would happen if you draw the rectangle? It's perpendicular to the axis of rotation, but it doesn't touch this axis of rotation. What would happen if you revolve it around? You get
Vinyl. No, they called it a washer.
very good. Who said washer? Yes, this is called a washer. You guys know what a washer is?
The metal.
Yeah, the thing that when you put in the screw so that it stays better, secures it better. Okay, so this is tomorrow's lesson. So all we're going to do is we're going to add up all of these different shapes, and then on the day after that, what would happen if the rectangle of infinitesimal width is parallel to the axis of rotation? I'm not going to give you the formulas now because I don't want to mix you up. Because this is the only thing you got on tonight's homework. I just want to show you these different shapes though. If the rectangle is parallel to the axis of rotation and you revolve it around, what shape are you going to get? No, a cylinder. Is that Suzaki again? Do you understand that a cylinder theoretically doesn't have any thickness to it?
It's a paper towel roll.
Okay, toilet paper roll is better. Some people call it a sewer pipe. Some people call it sewer pipe, toilet paper roll, but the official mathematical name is called a shell. Shell. You know, like the shell of a bullet or a cannon thing? Shell? Suzaki, no. This is a cylinder. Theoretically, it doesn't have a thickness. Like a sheet of paper has a thickness, but mathematically, it doesn't have, there is no thickness. Right?
There is no thickness.
Okay, so this is today's lesson. The next lesson, that's it. We're done. 4 things, right? We got slices, disc, washer, shell. Then you're going to have a couple worksheets, and we have a test next week. Okay, so let me give you an example of this. Okay, let me think. Let's say we have the region y equal x squared. This is y equal x squared. This is the line y equal 2. And of course, this is, that's not y equal 2, that's x equal 2. And this is x equals 0. So tell me, what is this point up here? This is y equals 0. You know, let's just start writing wrong things. What is this point up here, people?
4.
2, 4. Look, x equals 2, and then the y, oh gosh. Okay, here we go. Take this region. This is the region in question. I'm not going to even put this here in. Take this region, and I want you to revolve it about the x-axis. Can you imagine what shape that's going to give you? It's going to be like a Hershey's kiss. It's a Hershey's kiss pointing to the left. You understand what I'm talking about? It's like a Hershey's kiss, like, kind of like that. Okay, now you don't have to know what it looks like. You just got to be able to write an integral that represents the volume of this thing. So first thing we do, draw in the rectangle. Now tonight's homework, all discs. So if we're going to revolve it about the x-axis, the disc, your rectangle got to be touching the axis of rotation now. So that means you want to draw in the rectangle this way. Now you can do the problem by drawing the rectangle in that way, but then when you revolve it about the x-axis, what happens? Then you're going to get a shell. But we didn't learn the shell yet. You know what I'm talking about? So when you do tonight's homework, you got to draw your rectangle so that it touches the axis of rotation. So when this so instead of thinking of the whole graph going around the x-axis, just think of this rectangle and you go, hey, that's a disk. Okay, now what is the volume of a disk right there? Pi times the radius squared times the thickness. So pi times the radius squared times the thickness. Now how do I know that thickness is dx? Because you drew the rectangle vertically. You draw the rectangle that way, it's going to be dy. You guys get it? So those of you who are not drawing any rectangles, I can tell you right now, the test is going to have a hard time. Okay, so every single problem with tonight's homework is going to be pi r squared, and it's either going to be dx or dy over there. And all you got to do is ask yourself, how do I find the radius of this disk? Or the length of the rectangle? Top minus bottom, which is x squared minus 0. Add up all of these disks from 0 to 2, and that integral will give you this volume. That's exactly the volume of that thing. Okay, one more and we're done. Okay, same graph. Except revolve it about this line right here. This is the line x equal 2. Revolve it about this line. No, but can you imagine what that shape is? Yeah, it's like a Hershey's kiss, except it's like a taller one, yeah? And it's pointing up. Okay, so how should I draw in my rectangle? You gotta draw the rectangle this way, because all we know how to do is a disk. If you drew the rectangle vertically, when you revolve it about the line, you're gonna get a shell, which we don't even know. So you have to draw in the rectangle that way to get a disk. Oh, that's ugly. Now, when you draw in the rectangle horizontally though, what you gotta do is you gotta solve for x. See, like over here, you have y equals, you gotta do x equals. So what is the equation? Take this equation, solve for x. X equals, solve for x. X equals, I'll say it one more time. Solve for x. X equals root y. And of course, this is x equal 2, right? So what is the length of that rectangle, which is the radius of the disk? Right minus left. So again, pi times the radius squared. And what's the radius again? Right minus left. And how come I'm doing dy? Because you drew the rectangle horizontally. Add up all of these rectangles. Now, since you're doing dy, you got to go from the y coordinate here to the y coordinate up there. So, 0 to 4. Because this point is 2 comma 4, if you remember from that picture. Now, do you see the difference between a vertical rectangle and a horizontal? So, the key is, and I think I said this so many times already, the key is the rectangle. The rectangle tells you whether you're going to get a disc, a washer, or a shell. Yeah.
Wait, aren't those the two same graphs, but?
Yeah,
So how come one goes vertical and one goes horizontal?
because we've been doing this tonight.
But aren't they
Tonight's
the
homework is
same one?
disk.
How come the second one?
Oh, because this one, we're revolving it about the x-axis, which is this way. But this one, we're revolving it about this line here. So it's going this way. You guys understand that concept? Look, if the axis of rotation is here, then the rectangle gotta be like this to make the disk, right? But if your axis of rotation is vertical, then you gotta make the rectangle that way to make a disk, right? So this one's gonna be dx, that one's gonna be dy. Okay, we're done. Okay, so we need to decide, is the quiz tomorrow or Thursday?
Oh, wait,
Do it tomorrow.
What time is it? I got 6 minutes to make a decision. Yep. Yep. Oh, but no, either way, Tom's not gonna be here, so Monday, by 7:40, it needs to be done. Oh, I know what she's thinking, I'm calling in sick on Monday.
Friday, I'm not gonna be here.
What's that wrestling? Okay, Monday then.
I'm not gonna be on Friday.
Oh, no, you can be here tomorrow though, right?
Yeah, just Friday.
Oh, okay. No,
I'm just letting you know.
Okay,
This Spark, I'm not gonna be here on Friday.
okay.
You're gonna miss me.
Did I already sign it?
I don't need that signature. It's for school.
Okay. And this is cycle 7, yeah?
No, it's no one.
This is cycle 1, yeah?
The two numbers,
So Thursday, this would be like the last period of the day.
Oh, yeah.
Oh, Thursday's open.
Okay, quiz is tomorrow. So what is tomorrow? Yeah, yeah. Okay. Quiz tomorrow. So it's only on one thing, slices. So you're probably going to get 4 problems. 2 of them, you only have to write the integral. And then the other 2, you actually have to compute the number. Huh? And the one where you have to write the integral, if I don't see a dx or a dy there.
minus all.
Not minus all. Because I've been threatening to take off points, but I really haven't taken off points yet.